In summary statistics, we typically use two types of statistics to demonstrate the pattern of the data. One is the central tendency, and the other is variation. For central tendency, we usually use the mean to represent the overall pattern of the data. Sometimes we may also include the median when there are suspected outliers. Mode, which is the most frequently occurred value in the variable, is occasional use as well. For variation, there are three types of statistics that measure the variation of the data: variance, standard deviation, and coefficient of variation. Variance is the average square distance of each individual data point to the mean. It is hard to interpret, and we typically use standard deviation, which is the square root of the variance, and therefore measure the average distance of each individual data point to the mean. Occasionally, we will use the coefficient of variation to measure variation as well. Coefficient of variation is defined as the standard deviation divided by the mean. It is always between 0 and 1, and therefore it is useful when we are comparing the variations of variables of different measurement scale. In Jupyter Notebook, we can use the describe function to calculate the summary statistics of all the numerical variables. This function will return the number of observations, the count here, the mean, standard deviation, median, minimum and max, and the first and third quartiles of the values of the variable. We can also add non-numerical variable into this summary statistics table by adding the argument include equals to all. You can see that for the non-numerical variable, the qualitative variable, this table provides a number of distinct values in the variable, the unique. It also provides the most frequently appear value of the variable as well as its frequency, the top and the frit. If we are only trying to calculate summary statistics of a single variable, we can simply specify the variable name and use the describe function. If we are only trying to find out, for example, the mean, the median, and standard deviation of a single variable, we can simply use the mean function, the median function, and the standard deviation, abbreviated as STD function, to find the standard deviation of a single variable. We can also calculate the summary statistics of a variable based on the value of another variable using the group by function. So in this line of code, we are trying to find the mean of all the numerical variables based on whether the team won or lost a game. So we first specify the data frame, NBA games, and we'll use the group by function based on whether the team won or lost the game. So this would be based on the variable WL. We'll use a bracket to specify the variable WL. And then we'll use the mean function to calculate the mean of all the other numerical variables. And similarly, we can calculate the mean of a single variable conditioned on the value of another variable. The describe function can also provide important information about a date variable. So for the game date, we can see that the describe function returns the number of unique value in the game date variable. It means that the number of unique value here is 1,559. It means that there are games that happen in 1,559 different days. It also returns the most frequently appear date, 2015, April 15. That means that the date with the most number of games. It also shows the first and the last date of our dataset. The basic summary and descriptive analysis often involve visualizing the distribution of the data as well. We can visualize the distribution of a variable by creating a histogram. Let's create a histogram of the point variable, PTS, which is the point earned by each team. We can use the HIST function, the hist function, in Python to graph a basic histogram. And inside the function, we will specify the variable name using the column equals to variable name. In a histogram, the horizontal axis specifies the value of the variable, and the vertical axis indicates the frequency that this value occurs. We can see that most of the values of the point variable are between 80 to 120. We can also change the number of bins in a histogram. So let's say we want to specify 20 bins, which means that we will first take the difference between the maximum value and the minimum value of the point and divide it by 20 to find the actual interval size of the histogram. We can add the bins equals to 20 option inside the hist function. Sometimes for visual appeal, we may also want to leave some space between the columns in the histogram. In this case, we can simply narrow the width of the column. So we can specify our width equals to 0.9, which means that we want 90% of the width rather than 100%. So finally, let's save our updated NBA games dataset. Let's call it NBA_games2. And again, we want to export this dataset as a CSV file using this to_CSV function in Python. And we will use index equals to force so that we don't add additional row number, index number into the CSV file.